We're gonna get started today. We're gonna dive into some stuff pretty nice and quickly. But before we get started, I do want to give like a little bit of an overview. I don't want to take too long on it because I think it's like um, to a certain extent a waste of time to have your attention on very busy weeks and just be talking about logistics of a course that you don't have to be in. And so Rust book. I'm gonna pull this up as well. Um, all right. So. Yeah, to get started here, welcome. So this is something that I'm super excited about. I'm really happy that I have sort of like the ability to run um, this course. Like it's not formally a course. It has like the blessing of like several professors, I suppose. They've told me that like it's like a really cool idea of like what I'm doing. I'm getting a lot of feedback from different people, and so I'm really excited to continue it on this fall and oh, sorry, this autumn rather. When I looked at the name and I'm like, okay, should I name this Fall of Rust? And I'm like, that doesn't sound too great. So we're doing Autumn of Rust. But yeah, so this autumn we'll be spending several weeks together and going through the Rust language. We're going to be exploring a lot of stuff. We're going to be trying new stuff. But most importantly, I want us to be focusing on exploring, not memorizing and trying to get good for tests and all of this kind of stuff. And the reason for this is because I want this to be accessible to people in a lot of different areas. And so people who might be just coming into university, who might be just finishing university. Of course, there will be content that does sort of escalate past what people who haven't done computer science for the first time might be familiar with, but we'll do our best to make sure that at least you can get something out of what we're going to be talking about. So, before we get started, I'm going to talk about the code of conduct. I just want to look at my slides here because, okay, we're just going to use, I'm pretty sure I just went like, where did I put Rust? Here we go. So right here, I'm making use of the Rust code of conduct. Now, the code of conduct is something that's really, really important to me when I'm running this sort of iteration of the course. And the reason for this is because I want to build a community that's really geared around learning and helping people out, and not a community where people feel worried about talking, feel worried about like the other people judging them and a lot of this kind of stuff. And so I enforce it very, very heavily. And there's a lot of people that will be helping with this, keeping an eye out, making sure that interactions are always as good as possible, and very, very swiftly removing people who do not abide by the code of conduct. And so, one of the really big things I want to point out about this in the context of Rust is Rust has a lot of features that we'll be talking about. One of the largest features is the community. And the community is built on the premise that everybody is very, very welcoming. And because of this, we see a very, very large trans community who work on the Rust language, who use the Rust language. And to me, this just shows the power of in enforcing guidelines, making sure that it's inviting, and making sure that people feel welcome. And so I'm going to be putting this just in chat for anybody who wants to take a look. I'll be doing chat in Pub Chatter. There is like the tavern stuff, but like you could like do the voice channel thing. But since I'm not gonna be paying attention to Discord, I'll just have Pub Chatter open. So if you have any questions at any time, feel free to put it there. I did want to have something where I could have like a bot that you can like anonymously send questions to, and I can keep an eye on that. But I don't have it set up yet. If you DM me, well, I mean, if you DM me, then people see on the side, whatever. We'll try our best to stay anonymous where possible, but at the same time, I definitely want to make sure that we have an area where we can feel free to speak out when we like. So, um, oh yeah, okay, recording. I'll remove this part. My point about recording is, and I suppose this still stands when I'm gonna try to have a recording of what I talk about, but it's not gonna capture anything that anybody else says. And even like when with StreamYard, it's just capturing my Firefox window. It won't be capturing Discord. And so my goal with this is that people can feel free to speak up. People can feel free to put things in chat and not feel like their stuff is going to be posted on YouTube or other people are going to see it. And then this also extends to you recording. I would prefer that people don't record anything that is done, because if you're recording Discord, you're kind of circumventing what I'm trying to prevent. Yeah, so I want to talk a little bit about the inspiration for why I'm doing this. And so For a while, the University of Illinois has run a first year honors course in their second semester that teaches the Rust language. And the most interesting thing about this is that it's student run. It's students that give the lectures, it's students that come up with the assignments and tutorials, and they do everything themselves. And they only have oversight from a professor at the university. And so I went with one of the leads of it from the winter semester, and we talked about what types of things worked, what types of things didn't work, and I was really inspired by this. So that's one side. Another side is that the U Ottawa book, or rather, the U Ottawa CS Club ran a book club in the winter semester that focused on going through the Rust language, and I attended those. I met a lot of really cool people, and I was able to like learn a lot myself. And so I'm like, okay, well, if I'm learning by going through stuff that I already know, then me teaching is going to help out a lot. I also TA 1501, and I have a lot of sort of experience from things that I learned there that I try to like continuously improve and see in like the way that I teach and my pedagogical method. There's also a book called The Programmer's Brain that I'm taking a lot of inspiration from, specifically because it looks at the psychology of how we learn code, or rather specifically, the things that we don't necessarily do when we learn code. And so, kind of remedying some of these. And then more recently, there's a new Rust working group called the Rust Edu working group. And so it focuses on Rust in curriculums, Rust in institutions. And so I went to a workshop that happened in August, and I got to speak with a lot of people, a lot of professors teaching Rust at their universities, a lot of students who are doing different projects with Rust for pedagogy, pedagogical methods, and they really encouraged me to keep pushing forward with what I'm doing, which is like more the grassroots approach. And so to talk a little bit about how uh, the like sort of I suppose this slide was also for me to talk about sessions. So the sessions themselves, when I did in the summer, we pretty much went through the Rust book and we did a lot of content um, really based on that. And I think this is all right. I think that it gives us the ability to like have sessions where I explain things, and if you missed a session, you can go read it from the book, which is pretty detailed, and you can explore things in more in depth. But I definitely understand that like it's a pretty dry way of doing it. And so I have each session laid out to be about an hour and a half. But that being said, I want to try to keep it to an hour for the most part. And the reason that I want to make these changes for this semester in particular is because I know when we are in our course, we have potentially five other courses. I have one course, and I'm like, how do I put other stuff on my plate? And so I think for a lot of us, this is definitely cutting into a lot of other education things that we have. And so I'm sort of taking my learning objectives that I had last semester, which was exhaustively make it through the book, to this semester, which is learn specific concepts that are really, really helpful. And so this is what we're going to focus on today. We're going to kind of explore what I mean by these learning outcomes and why it's worth learning Rust in the first place. And so we have the sessions, and then we have labs. And I'm going to say that the labs are like a lot more optional than they were in the summer. And in the summer, I really encouraged people to do them. I would check in with people. And the reason for this is because I wanted to like reinforce a lot of the practice. But then on the other hand, when it comes to labs right now, that's literally just basically another assignment on everything else that you're doing. And so I do want to try and keep them small. I want to try and keep them fun, but I don't think that they're going to be or I think that they would be more invasive than they were over the summer. So we'll kind of feel out how they go. I just put out one of the labs today, and we'll be taking a look at that later in today's session. Yeah, so we'll feel it out. We'll see how it works. Yeah. So the next thing I want to quickly talk about is some more of the methods of how I'm doing things. And so I have this idea here: everything is open. And what I mean by this is that when we are looking at all of the labs, when we're working on our own labs, it's all open source on GitHub. And I really want to encourage a lot more sharing of information and helping one another rather than feeling stuck at certain places. And so this is very, very contrary to how stuff is done at university with academic misconduct. And I do want to make it very clear that this isn't necessarily something that the university should be doing. It's because I don't ask for grades. It's because I'm not trying to mark people. It's because there aren't any you haven't paid for a course, it's not accredited, all of this kind of stuff. So once I take that all away, once I strip it down, I'm like, okay, well, the best way to learn is to learn together. And so let's take a quick look at how some of this works. And I want to go to Seasons of Rust, and I want to go to some repository. Let's go to like lab 2. So lab 2 is the one that I just released. Naming scheme's a bit weird because I called the first lab like intro lab, and then suddenly we're skipping to 2. So it's like, where's 1? And it is what it is. But okay, and I actually forgot this was like the Rabbit University one. So with the labs, as we can see here, and so one more thing I do also want to acknowledge, we did have a GitHub workshop last week, but at the same time, I don't expect everybody to be like super experts on GitHub by any means. And so I'm going to breeze by a few of the terms here, like repository and stuff like this. But just be aware that anytime that you run into any issues whatsoever or have any questions, all of these questions are super welcome on our Discord server because, well, rather, during the summer, I spent a lot of time helping people through getting started with GitHub, learning how to do some basic interactions, because one of the learning outcomes of the Seasons of Rust is to learn more about GitHub as well. Okay, so got a repository, got all the questions here. And I don't know if I've made a commit with all the fixes. It looks like I haven't. But if I go back to lab 2, I just want to go find one from like the past. All right, I'm going to go take a look at Melissa's. And so Melissa, she had hers working. And so she made the commits to get it to work and stuff like that. But this repository itself is public. And so let's say you are stuck on one of the labs, you're not really sure what to do. You always have the ability to go look at what other people have done for the questions, how they've solved them. And not to mention, this is a really good way to learn because it will help you sort of break out of what stuff you might expect to see in certain areas or the way that you might have solved it and kind of be able to explore some different options. And so, of course, the first few labs are pretty linear. Like it's like when you're solving it, there's really only one way to do it. But in some of the future labs are more open-ended. So, all right. Yeah, so as I mentioned with questions, you can ask them in Pub Chatter. I'll take a look. Nothing there right now. Perfect. And then the anonymous side, I'm still working on that. There's ways to like I could set up like a Slido or whatever and get questions on there, but yeah, we'll sort of see how that goes. Another thing I want to mention is so missing a week because I wasn't recording over the summer. This was a bit harder. Let's say like you missed a week and you wanted to catch up. Since I'm basing a lot of what I do directly off the Rust book, it's pretty easy to say, okay, go read this chapter, get all the information from there. But I do also want to try and accommodate for people and make time to have either one-on-one sessions or small group sessions to be able to go through content. And this doesn't even have to be if you've missed a week. If you are just finding some content doesn't make sense, then I would love to sit down and help you out with it. Partly to get you up to speed, but also because I want to learn what I can do better to explain things. And trust me, there's a lot of stuff that we're going to be going through that is pretty exciting compared to a lot of content that we learn in school. Well, I mean, I guess if I'm taking 3804 right now, and I would also call that content very exciting. But there's some topics in Rust that we'll need a couple rounds to get through, and so I definitely want to make sure that we're pulling along everybody as well as we can and not leaving people behind. But also that being said, I do want to make it like, or yeah, one thing I sort of felt was, or that I've seen is during the summer when people came for the first few weeks and then didn't come after that, they felt like they owed me like a debt because they stopped coming to what I was running or something like that. And I don't want that to be the feeling at all. I know that like a lot of what I'm asking is a lot on top of your semester, and not to mention the topics that we're going over might resonate differently with different people, and depending on your experience, depending on where you're at in your university career, might not be as accessible for you, and so that's completely okay. Yeah, so next up, the mentors. So I have a group of mentors, and I'm trying to figure out how I can better use them this semester. I really want them to be the ones that are doing like a lot of the code review on. Here, I'm just going to go to Melissa's repo again. So this is the second lab. And so on each lab that you create, on each repository, a pull request is created, a feedback pull request where I'm able to go in and there's like comments on code. Well, actually, it's not too bad. So I was able to go in and like make some comments here, make some suggestions for some changes. And so I really want the mentors to be helping it with this. as well as being able to answer questions. And so, well, you're able to see my screen. Everybody's on the Discord already. But if you on the Discord, if you go to there's like a questions forum, and so anybody can ask any questions there. We have a lot of people that are willing to help, and a lot of like really smart people too who are in this Discord. And so I'm super excited to well also have brought on mentors from the summer, people who have made it even like most of the way through the summer. I gave them the option to be mentors if they like, and so they'll be able to check in with people and kind of answer questions, give feedback, all of this kind of stuff. All right. So let's dive into the why Rust section. And so this is one that I've tried to grapple with quite a lot, and of recent I've gotten a lot more validation for it. But the question really comes down to why would you spend your time when you already have so much else going on? Why would you spend your time with me learning a language that's not required at university? And so there's a lot of different reasons, and I've broken them down into like how it can help you with different courses at Carleton. So, for example, Rust is like a multi-paradigm language, and so it has some functional inspiration, which is going to help you when you get to 3007. It'll help you see through some of the content there. Then on the other hand, Rust is a systems programming language, and so you can draw a lot in terms of what C and C++ have, and sort of like take the Rust learnings and apply them there. Or like in 3004, when you're doing like a lot of software engineering, you're thinking of like bigger projects and stuff like that. We'll be exploring some stuff there as well. And so there's that side. It's like, okay, well, but from that perspective, we also have other languages as well. Now, Rust does bundle a lot of benefits together, but why am I not teaching you Go? Why am I not teaching you Kotlin or a lot of other modern languages? And so the one core reason that I want to teach Rust is because of its properties related to memory safety. And so these are things that I mean most popularly manifested in terms of stuff that we see in 2401 when we segfault. When we segfault, it means that our program went and tried to do something that it didn't really know how to do properly. Maybe it tried to go look at some memory that wasn't actually owned by the program. Maybe it tried to free some memory twice and the operating system caught it, whatever. There's a lot of stuff that can go wrong in computer memory, and Rust gives us some foundations so that we cannot have any of the things here go wrong. And so that's like a very abstracted answer to this question that makes sense to me because I know what the borrow checker is, but doesn't really make sense outside of that. So let me make it like a little bit more, like give some other examples. And do I have I don't know if I have a why Rust. Okay. Um, so a few more concrete examples of this. Microsoft released a article several like a few years ago about how they estimated that 70% of the security bugs that they've found and fixed are related to memory safety errors. And so this is an entire section of bugs that if the code was written in Rust would not be able to would not some edge cases be able to manifest. Similarly, there's and we'll sort of explore some of this later. There's a lot of other ideas surrounding stuff like dealing with null values in languages. Like if you've heard the term dereferencing a null pointer, if you've heard the term like for example, maybe you're using Python, you say like this variable equals none, or maybe the variable equals 5. But if you say 5, like you add 2 to that variable, either it's going to add to 5 and it becomes 7, that's cool, or it's going to add to none and it's going to crash. And so there's some other stuff around here as well that Rust gives us very good facilities to work and solve problems for. But then more importantly, the things that we learn as fundamentals in Rust allow us to, or fundamentals and foundations rather, allow us to branch out to other languages as well. And so I'll try to give an example of that today because there's a pretty cool one in some Python code that we can take a look at. Yeah, so that's the first part. The why Rust mainly comes down to the stuff on memory safety and some other concepts that we can also learn that aren't necessarily in every other language. And then second of all, why me? So I mean, maybe it's just because I am the person who's running something cool on the side of school, that kind of thing. But I do want to give a little bit of background about stuff that I work on in like the Rust language space. And so Under governance right here, if we go to the game development working group, I'm a lead of the game development working group. And for this, I do like a lot more outreach stuff. I do like a monthly newsletter. I run like a monthly meetup for game development. And I work with there's like a lot of other cool people on this team. Like I co-host a podcast with Richard, with Joe and Andre. We do the newsletter together. I run a graphics meetup with Kavark. Erland has done some really cool stuff in like the more like open source game development space as well. Johan is I think he's the CTO of this game studio called Embark. And so there's some really cool people here that I've got to work with. And then the other thing is I work on an open source game called Valoran. And Valoran is written entirely in Rust. And we've been, well, for a little bit now, we've been like one of the flagship examples of what Rust in general can do, but also Rust in game development. And so it's been really cool being a part of this. And in fact, I think so. In the Summer of Rust Discord, we have some people from the Valoran side of things as well who can answer some pretty complex questions. They're very smart people. So yeah, and other than that, I'm like, there's the other stuff. I'm like the vice president of the Carleton Computer Science Society. I also am like a GitHub campus expert, and so that's a program that GitHub runs to have leaders at or help out leaders at different institutions and universities. And so yeah, that's the why me session. Okay, that's it for presentation. Now we're gonna hop into learning a language, and so we're gonna try something. We're gonna try something a little bit interesting. Let me just check and see what chat is. Okay, cool. We've got quite a few people here. So we're going to start with not even learning anything with the language first. I've told you that Rust is all this cool kind of stuff. If you've read like the intro document, there's a lot of other things as well that we've taken a look at. But I want to try something a little bit different. What we're going to do first is we're going to start with some code reading. And so now from the outsides, looking at this, there's a lot of stuff going on. I haven't even looked at this file. There's some like stuff here that I definitely don't know enough about. And this file may or may not be a good example. I looked for it very quickly. But we're going to try to look through some code and pull out a little bit of structure. And so we're going to do a few different steps here. And we're going to kind of see how it goes. And so what I'm going to do first is I'm going to put this in chat and then just a little bit of a highlight on how to use this. We're able to select a line and then color it a certain color. So I can go like this. We can also click and drag and draw links between colors, I believe. Yeah, okay, so I click on it and then I can click down here and kind of like draw like a line right there. And okay, I'm like, as I'm looking at this file, I'm like less and less convinced that it's the best one to do. It's all right. This is sort of the point of what we're trying to do. So I'm going to put this in chat, and I'm going to give us 5. What we'll do first is we'll do a 1-minute session. And with this session, what I want you to do is look through this file, and what you're going to do is you're going to find 3 lines that stand out to you. And so when you find those lines, what I want you to do is just write in chat, and I'll also post this link. So don't worry. And maybe we'll do 2 minutes instead. We'll do 2 minutes. But I want you to find 3 different lines that you find the most interesting. These could be anywhere in the file, and you do not have to explain why whatsoever. And so essentially, like let's say, okay, I like line 50. I'm just going to say, okay, 50, and then pick 2 others. And so we'll start the 2 minutes here. Don't worry too much about reading too in depth about all of the comments and all of this kind of stuff. And in fact, what we're trying to do is just look at things that kind of like spark our attention. If you're looking at this from a first year perspective and you don't know anything about code, don't even worry about it. Just pick out 3 lines, doesn't even matter. So we'll get started here with a minute and a half. Feel free to look at it, and then once we are at the end of the minutes, we can put some lines in chat. I'm just gonna mute myself here. Yeah, this is a really interesting one to point out. I especially like looking at it from the perspective of, okay, well, how do we sort of compare it to other languages that we've seen before? And what are all these like separations that are happening here? Because when we're familiar with like declaring variables and assigning to them, we're expecting that we can evaluate the stuff on the right hand side to some piece of data, but there's a lot happening over there. So that's definitely a super interesting one. Now, just again as more of like a warning, very little of the code that we're going to write is going to look like this. This is code that's like a lot more low level trying to do stuff, and so I should have picked a file that's like more semantically near the surface. But that being said, it's still pretty cool to kind of look at this and think, what's going on here? Yeah, so that was definitely a great one. Anybody else have any they want to bring up? All right. So a few others that I'll point out as well. I heard one group talking about line 78, 78 and 83 right here. Sort of a point about we have this keyword impl, and then we have this other pub function, pub fn right here. And so this is like sort of like an interesting combination how the pub fn is inside of whatever the impl is. Um, and then, well, we have like unsafe line up here, which I mean on its own already has a lot of the Jay-Z. Um, um, oh, is StreamYard okay? Yeah, StreamYard okay. So yeah, a lot of like the interesting stuff going on here. Whatever, add some other lines. Um, so another one was talking about sort of like the how this function. Sorry, I want to not say stuff in terms of what it actually is because then it implies sort of a inherent you should know this type of thing. So I want to be talking about how things look, not what they are. So this is a function. We'll see that very soon, but I should be calling it fn just to make sure we're all staying on the surface level here. Yeah, so this one's like another interesting one. Um, I think we were talking about the pub keyword right here and sort of like how it was looking in terms of like where it was placed. Um, Another one, so one group pointed out that this section right here was really interesting. How we see the pub fn like we did before, but it continues on to something that says where. And so we were kind of wondering what does the where keyword mean and what like why is it here for this fn but not on other fn's and kind of like what this entire section sort of means in comparison to other ones. And so that was really cool. Um, and then another look at like the unsafe keyword here. And so one of the other ones down here is sort of how this line has a lot of nested sections right here. And so we have something like on the outside to hold all of this the stuff on the inside, and it appears to be talking about like operating systems. You've got like Mac OS and Windows, and so that's definitely like an interesting line as well. And then actually, I think that was just like a different select one. So, anyways, I mean, although I went out and found a file that was way harder than it should have been, I think like it was really cool going into groups and hearing kind of what people were looking at and what people were interested in. And yeah, I think just surveying a file like this, I mean, I don't know how many people have gone through and looked at code like this before, but we literally just like went and looked at part of the renderer for a terminal emulator. And so I use Alacrity on my computer. Um, it's like this really cool thing that everything that you see here is like done by Alacrity, like the way it renders, the way it does stuff to the screen. And I think we went and like literally looked at the render of it. Yeah, like of like the I think this is what we were doing. Yeah. So I mean that's pretty cool. But now that we've done that, we're gonna take a step back. And so for this next half hour, we're gonna take a look at a little bit more of Rust from the surface. And so we're going to be going through some stuff in the Rust book here. Now, for a little bit of context, the Rust book, or the colloquially known Rust book, is a book that's written by people who work on the language. It's open source, it's free. You can get a paper copy of it, and it's a I think it's a really good reference for people who want to learn Rust and have a lot of experience in other languages, and it's a pretty good reference to learning Rust if it's your like if you're trying to get into languages near the start. But there's some stuff that I think the order of can change a little bit. And so the way I did it in the summer is I went like three and then part of four, and then we did like five, six, seven, and then we did like the other half of four, and then we did a few down here, and then we came back to four again. And you'll be realizing like a pattern here. Four is like a very loaded chapter. There's a lot of stuff in there, and it's just a lot of new ideas. And so we'll be taking it at some different paces here. Um, and so what I'm going to do first, though, just because I want to make sure that we have enough to kind of work our way through the second lab here. I'm just taking a look quickly. So I think we need to talk about functions. We need to talk about math. We need to talk with some variable stuff. Okay, cool. So I think we can get that done in half an hour. And then another thing I'll mention is that right here I'm on. I'm just gonna make sure I'm sharing my screen. All right. So, yeah, we're all good. Okay, cool. So this is called the Rust Playground. The thing that I'm on right here, it allows me to write Rust code in the browser and execute it. Maybe in the future I'll use VS Code instead. And I think it'd be easier for some stuff in VS Code, but more importantly is just I don't want to like switch screens for the recording. So we're still trying stuff out here. We're seeing how it goes. So let's talk a little bit about some starter concepts in Rust. So I'm going to start out with a plain file. Let's just do a hello world. I'll do it in, I wish I could make the text bigger without making the entire screen bigger, but I don't know if I can. I hope this is all right. And so I'm just going to go print line hello world do. And I'm going to run it. I'm just going to make sure that I didn't make any mistakes. And it's going to say hello world. Okay, very cool. So let's break down what we see right here. So 3 lines of code, pretty nice, short and sweet. A few things to note here. When we have this body right here, I do have to have it within this main function. That's like the entry point of a Rust program. And so if we take a look at the syntax here, we see we have the keyword fn main, where we have print line. And I mean, if I was comparing it to Python, I would do like def main print hello, like that type of thing. So very, very similar. But of course, in Rust, we have braces. And so if you're familiar with Java, C-like languages, I think is a term, and a lot of this kind of stuff, this might be a little bit more familiar. As for like the function itself, in Python we use def. In Java we use I forget. It's like public static void main. I think that's what you say. That's what like I've been trained to say after so many years of using Java. But we have fn. We have the function name, parameters. Println itself is a little bit interesting. It's a macro, and so it has this exclamation mark here. The macro basically lets us do more things inside of the parameter right here. But for a good chunk of my first few times, like learning the basics of Rust, I could sort of just write this off as, oh, this is how it looks, this is how it does stuff. And let me just quickly go like this or something, and I can go forest, and then it's going to sub forest into there. Pretty nice and easy. I'm just going to go like this and do Rust. I like to try to toss some of the code in chat so people could take a look at it themselves. And actually, well, let's just even do this a bit better because I'm in the playground right now. I'm just going to send a permalink to the playground. You can click on that. You can open it up. You can run that code yourself. You can tweak it around a little bit. And so that should be a fun way to do it. Okay. So that's like the very starter, but I want us to talk a little bit about some of the more interesting ideas surrounding variables. So I'm just going to copy this code. One of the really cool things about the Rust book is that there's a lot of opportunities for code that is in the book to be used elsewhere. And so I'm gonna. Okay, I wish so I have like this cool Rust bot in Discord where it like quizzes with questions, and so I put some code in, and you have to guess if it compiles or not. So we'll play a game of compile or not. Okay, will this compile? And then do, do, do. Okay, and so you can vote on if you think this code is going to compile, and I'll also toss it in here so you can see. And I mean, this is very much like you don't know anything about the language yet, and if it doesn't compile, it's probably not going to compile because of something I didn't explain to you yet, and so it's like I'm scamming you pretty hard here, but um, hopefully it like makes the lesson easier. I don't know. We'll see. All right, so we got equal on both sides. So we have half the people thinking I'm about to scam them, and half the people believing that like this is a first test of a quiz and everything should go all right. So let's take a look and see. Will it compile? No, it doesn't compile. Woo. Okay, so let's talk about why it doesn't compile because this is a really interesting idea here. Um, so Rust has a very strong understanding of mutability when it comes to variables and values. And so what I mean by mutability is the ability to change something after it's set. And so in this code right here, I say let x equal 5, and then I print the value of x is whatever x is. And again, this syntax, this print line syntax, I apologize for not explaining it all right now, but if we look at it, we're like, oh, okay, there's like some braces here, maybe like it's just going to sub x in, and that's exactly what it does. And so we'd expect it to print out value of x is 5, then we say x equals 6, and then we say the value of x is 6. So mutability is sort of interesting. Um, by default, when you make a variable, it's never allowed to change again. And so the term we use is it's immutable by default. And you might hear about mutability in different languages or in different contexts in courses or whatever. But in this context right here, we say once x is 5, it's not allowed to be assigned to again. And so when I run the code, then what I'm going to see down here is cannot assign twice to a mutable variable x. And one really, really cool thing about Rust is that the compiler is going to be very, very helpful when it comes to fixing problems. And so in this code right here, and let me just, I'll put the permalink to this in chat as well, so you can go to that playground link and take a look at it for yourself. And then also follow along as I fix it here. So once I hit run, this all comes up, and then it says on line 2, I said let x equal 5. This is the first assignment to x. But it gives me a help right here. It says consider making this binding mutable, mute x. Now it doesn't show me like exactly how I changed up the line of code, but if I just put the mute right before x like it shows right here, so I say mute x equals 5, and I run this again, then everything's all right. We're able to go and say x equals 5, and then later say x equals 6. So the reason that immutability is so important and the reason that it's immutable by default is because we get a lot of benefits once we're able to look at a variable declaration and know if it's going to change later or if it has the potential to change later. And so once I say let x equal 5, I know that no matter what happens across the entire code base, x is not going to change under my nose. And so this is a super powerful idea. We see it a lot in functional languages. And we'll actually be exploring this a lot more once we start diving into functions and how variables move between functions. So with the mutability itself, the Rust book goes on to explain, okay, here's a compiler error that we were talking about. I'll also toss this link in chat. Does that mean we'd have to change everything that can change to mute? Yes. Yeah, so that's a really good question. I almost said your name, but I'm trying my best not to get a good recording where it's just me. Yeah, so what this means is whenever you're coding, when you define a variable, so let being the keyword we're going to define something new, and then I might use the mute keyword after. Then the variable name and then the value. We have a very interesting type of thing that happens here because like, okay, well, do I have to do that every time? That's so annoying. Oh my goodness. So why don't I just always make everything mute? And so what's going to happen here is I'm going to get a warning. It's going to say, you made this variable mutable, but it doesn't need to be mutable because after this line, after line 2, you're never going to change it again. And so now that being said, it still does compile, but it does come with a warning. And so with mutability, though, we'll soon find that the ability to keep things immutable does help us a lot in the way that we think about our code, and the way that our code flows and the way that our code changes and all of this kind of stuff. Okay, so continuing on, Again, when I went through with my section in the summer, we did dive into a lot more of these paragraphs. It can definitely be supplemental material, like you can go through and read a lot more, but I'm going to try my best to explain it in my own words in the way that it's sort of explaining stuff as well. So it comes up with the same solution. It uses mut x equals 5. Constants I don't care about too much right now. Shadowing, we're going to skip. Woohoo, we did like a speed run of that part of the chapter. Okay, so let's talk about data types now. And so Rust is a statically typed language. You have to say every single type when you're writing stuff out. And so whenever you declare a variable, Rust has to know its type. Whenever you're passing stuff from function to function, Rust needs to know its type. But I'm telling you this, and I literally just ran code where I didn't specify a type. And so this is something that's really interesting, is that Rust will infer types wherever possible. And so what I mean by that is because I said this is 5 right here, Rust is going to infer that this is of type integer. And similarly, if I made a string, then Rust is going to infer that it's of a certain type of string. And so let's take a look here at what would happen if I actually wanted to explicitly say what type this variable was. So again, let's take a look at the semantics of how to declare a variable. I say let because I'm going to start declaring something, mute because I want it to be mutable. Now, also the pronunciation differs. I don't think there's like a, so I say mute as in like the first part of mutable, but a lot of people also say mut, and so I think it's up to the ear of the beholder or whatever. I don't know. So then we say the variable name and we specify a type. And so I'm going to say this is an i32, and I'm going to compile it, and it's going to run, and I'm going to say let or x equals 10 or 20, just so it's all happy and fine and dandy. Okay, well, it's not fine and dandy because I'm not using it a second time, but now it's going to be hopefully fine and dandy. No more compile warnings. Awesome. So I just tossed an i32 in here, but i32 by itself doesn't really make too much sense. In fact, I can even say i8, and this will still work. I can say I128, and this is going to work. But I'm being very specific with the numbers I'm choosing here. I can't say I this and it will work. That's not going to be happy. It can't find that type. So when we care about data types, we have a lot of basic data types. We have stuff like booleans, we have integers, we have floating point numbers. I don't want to spend, well, how much time we got? Okay, 20 minutes. I don't want to talk too much about the magic behind it, because I know some people haven't really explored like data types and how to store bigger numbers and stuff like that. But what I will say is I8 will allow us to store numbers between negative 128 and 128. And so if I think if I go 129, then it's going to tell me I'm not allowed to store it. That's outside of the range. But if I just double the number right here, so go from 8 to 16, then it's going to allow me to do that. But then that number can only go up to 65535. So if I do 65536, that's out of range. And actually, it will even tell me the range of I16 is negative 3278 to all the way up to 32767. So the other thing I want to show off here is what the I means. So I means integer. It means that it's a signed integer. So I can have negative numbers. I can have positive numbers. But if I change this out to a U16, then what's going to happen is it's now going to give me a different range. It's going to say you're not allowed to fit 65536 into this range, because we can go between 0 to 65535. Now, what it comes down to is we have 16 is the number of bits that is storing this number. When you look at binary, it's like, okay, how big of a number you can put in there, all of this kind of stuff. Moral of the story, and what I will say as like a very good blanket statement, and I mean Rust also says this, is that I32 is the default for a lot of stuff. I32 will allow us to store a relatively big number, not that big, but it'll tell us right here we can store a number between, so this would be 2.1 billion, so negative 2.1 billion and positive 2.1 billion. Let's take a look right here. We have length is like how many bits it is, and that's how like with the longer the length, the bigger the number you can store. So we have signed numbers, we have unsigned numbers, we have I8, I16, 32, 64, 128. And I mean, if you look at these numbers, you know they're all powers of 2. And then we have unsigned as well. So I'm not going to dabble too much in that for now. It explains more of like the logic behind here a little bit. We can also have like different binary representations and stuff. I don't think it's too important. So let's show off a little bit about type inference. And so type inference sounds it sounds like a thing that it's like, oh my gosh, that's so complex. How am I ever gonna like figure that out? And that's one of the things I like about sort of like teaching some of these ideas is like there's another term, monomorphization. Ooh, that sounds rough. But once we get to some stuff later on, we'll get to explore that. And there's like some, oh, okay, kind of cool. So let's take a look at type inference right here. If I say let A equal 1, let B equal 2, let C equal A plus B, then this is going to be fine. I mean, it's going to compile. It's not going to do anything. Let me just print line C. And you'll also notice I have semicolons at the end of each line. If I don't have stuff there, it's going to complain. And we'll talk about some of the cases where that's not necessarily what happens. Okay, so print of 3. If I do 2.0, then what's going to happen here is, well, I should have asked again, is it going to compile? That would have been fun. But I didn't. Well, actually, I'm just thinking of my bot. What if I wrote code here and then I shared a gist and I typed it into the bot and then it asked people? Oh, that'd be kind of cool. Okay, I gotta like take a look at that for the bot. That'd be nifty. Okay, so Rust now says cannot add a float to an integer, and it will say right here when I say let C equal A plus B, it says there's no implementation to allow for an integer plus a float. And then a whole bunch of other stuff here about what you could do to make that happen. But in this case right here, where okay, I'm also just gonna so that one makes sense. You're trying to add an integer and a float together, and that's not compatible. So what I'm gonna do is I'm gonna make this an I32, and I'm gonna make this an I64. And so right here, Rust is going to go in and it's going to figure out what B is because of how it's being used in this equation right here. And so Rust says, okay, well, what we're going to need to add these two numbers into, it needs to become an I32 because that's what C is. And so Rust expects there to be an I32. So it expects an I32, but it found an I64. And the reason it found an I64 was because it tried to add A to B. And Rust doesn't know what B is just yet, but it does know what A is. It knows that A is an I64, and it doesn't know how to add an I64 and an I32 together. And so instead, it's going to try and it's going to set B to be an I64 as well. But another way to look at this, if I remove these right here, then again, it's going to complain. It's going to say you're trying to add A and B together. We don't know how to do this kind of stuff. Now, I'm dilly-dallying quite a lot on this. At the end of the day, when you're writing code, when you're doing stuff in VS Code, it's going to help you out a lot with this. But I do want to make it clear that you don't always have to say what the type of something is. But if Rust can't figure it out, then it will ask you. And so, anyways, that's sort of like the stuff that goes on. We got the wishy-washy compiler magic happening in the background that's doing some of the heavy lifting for us. So I very willy-nilly just went and did like some addition right here. Addition, multiplication, subtraction. This is all pretty similar to what we'd expect in other languages. Nothing too interesting there. I'm going to potentially sneeze, and I don't. I was going to say I was not able to mute myself fast enough on both platforms, and so everybody got like a very loud noise. Okay. We've got Booleans, we've got. So what I'm trying to do here is I'm trying to skip stuff that I assume is, well, I assume to a certain extent is familiar from if you've coded in another language, then it's what you would expect. And then just explain like what's a little bit different. When it comes to the lab itself, I'm going to kind of see how this pays off. It could be that people try out the lab and they're like, oh my gosh, you did not explain how any of this works. And in that case, what I want is people just asking a ton of questions on the forum, and we can go through stuff there. So that's why I'm skipping all of this stuff for now. I can come back to it later. Cool. Let's talk about functions now. So I'm just going to copy this code right here, toss it in the playground. I'm also going to look if there's any questions. I don't think so. We're good for now. So let's do another round of does this code compile? And then All right. If you think that code compiles, we'll get some votes in there for a few seconds. Yeah, so the interesting thing about the book is that it does not always have code that compiles, and I have not told you how to look out for whether or not a code block compiles or not. So who knows? It may not. So let's see what we think here. All right, it's pretty overwhelmingly yes, and so I think I like the controversial ones. I like when it's like 50-50, because all of them I'm asking you to use intuition of like something that I haven't given you knowledge for. And so I love seeing like the distributed amount, but if it's all 100% one side, and also to specify in the future. So if there's like a lot of people voting on one side, then you're less inclined to vote on the other in the future. Like the way that I do the quiz with my bots, it tells it. It doesn't say up front who voted on one side. It just says who's right at the end, and then you always have the plausible deniability of because your name's not listed there. It didn't say you whether or not you voted. In which case you're just like, oh, I didn't vote, and then so anyways, game theory wise, it all works out. But I agree that like that the way I have it set up right now isn't the best. Okay, so does this code compile? Let's see. Woohoo, it does. So hello world, another function. We saw right here that we have like the print line and then it calls a function. The function is defined down here. One of the interesting things to point out in Python, sometimes you require functions to be above where they're called because Python's interpreted, it goes and reads through every line of code. Once you get to another function, it's like, well, I haven't seen another function yet, so what am I supposed to do here? In this case right here, since it's all compiled, it's all below, that's fine and dandy. I forget the term for that, but it is a problem in some places in some languages, and I find it very interesting. But we have functions here. So let's try. Okay, here, let me write some code and then we'll do it. Does this compile? So let a equal 5 and print a. So I'm gonna try my best not to make stupid mistakes and like do like a scam thing. Add 10. Okay, so we'll just call this function add 10. And we're gonna pass in a, and down here, I'm gonna say that this is a function that takes in a num, which is of type i32, and it's going to return an i32. And I'm going to say in here, return num plus 10. And then here I'm going to say let b equal that, so whatever it returned, and then I'm going to print out b. And okay, so this code right here, declaration hoisting. I think yes. So there's I forget the exact term. That might be it. Like yeah, the term for going through and finding whether something exists already or not. Declaration hoisting. Yeah, that must be. It must be. All right. Do. All right. So do we think that's gonna compile or not? All right. I like this one. I'm definitely going to try this to make the bot sort of like do this because I love this. I kind of just write out some code in my mind. Like I'm like thinking as I'm coding, like, okay, is there like a little thing here? Is there not a little thing here? We'll see. Oh, okay. So we're getting some interesting votes in here. And to be honest, I mean, it could not compile because like I just make a mistake or something like that. I'm trying to see. Okay, so I think the votes are in. We see overwhelmingly no, it's not going to run here. So let's take a look and see what happens. Okay, it did run. It did run. No scams this time, but let's think about what scams could have been there, because I think this is most interesting. Um, and so, I mean, if you want to put in chat why you think it may or may not have worked, definitely feel free. But I'm just gonna like take a quick analysis here, and I'm pretty sure the reason people would think that it wouldn't work is because I didn't add the mute keyword here. Um, so this is a pretty interesting one. Um, because I mean, actually, it's telling me a lot as well about what I like the way I sort of described mutability. Because the way I said it is that the variable cannot change. And what appears here is that a variable changed, even though I didn't use the word mute at all. Um, oh yeah. So Emilian, good point. I did the thing. Okay, whatever. I'll try to cut out the recording, or something. I'm trying my best not to say names. um, it's all practice. All practice. Okay. So the point that was just brought up is having like the syntax in here. There's like a new Rust feature. It literally just dropped like 2 versions ago or something, where you can have like variables inside of here. I forget the name of it, but everybody's very happy now. You don't have to write out like a long print line type of thing. So let's talk about mutability here. In this, I declared a to equal 5. I then said that I'm going to print out a, so rules are still fine. I'm not changing a by line 4. Now let's take a look at line 6. First of all, let's take a look at, well, okay, so we're calling a function and we're passing a into it. And then whatever that function returns is going to get assigned to b. So let's go look at the function now. And before we go too deep, let's break down what the function header looks like. Or sorry, the function signature is a term. So the signature being this entire line right here. We have the keyword fn for function. We have the function name. That's good. It lines up. And then in the parentheses, what we'd expect as parameters, we have something called num. And so that's me saying that I'm going to have a variable inside of this scope called num, and it's going to have the type i32. What I should have said, and maybe clarified as well, just another thing I'm thinking, is I won't try to scam on semantics as much as possible. And what I mean by that is, let's say instead I wrote def add 10 num, and then I'm like, oh, you thought this is going to compile? This is actually Python. Gotcha there. I'll try not to do that as much as possible. I want it to be like much more interesting, related to like what we're learning. Now that being said, there will be some of those gotchas in the future. But okay, anyways, parameter we have num is of type i32, and then at the end here we say what we're returning. We're going to return something from this function that is an i32. And so if we read the entire line here, we can say a function called add 10. It takes in a variable called number, which is of type i32, and the entire function is going to return an i32. With a reminder that i32 means it means signed integer 32, but we can just look at it as an integer pretty much. And then inside this function, we're going to return num plus 10. And then we're going to say let b equal this. And so let's break down why it didn't fail, and specifically around the mutability here. Well, as a got passed into here, so a got passed in and it's now called num right here. But at no point did we ever say that num is equal to something different or a is equal to something different. And so that's why we don't have to put the mute keyword in here, is because a doesn't change. Now, on the other hand, we are returning from the function with a new value, and that gets assigned to b. But that value itself is completely allowed to move around and be assigned to b, and it's separate from a. Now, as I'm saying this, I'm like, oh my gosh, I'm shooting myself in the foot so many times because I'm about to like ruin everybody's dream. And like when we get to the next section where I'm explaining ownership and borrowing, the rules change. But for now, we're just looking at semantics as if we'd expect this to be Java or Python or anything else. Yeah, okay, so we got some really good questions here. Okay, yeah. Yeah, so the name thing, I'll consistently do my best. We'll see. Out of curiosity, can you return more than one variable? I love this question. So there's a few different ways that we can return more than one variable, and some are better, some are worse. One of them is we can wrap stuff in what we might call a tuple. We could wrap stuff in an array. We could do stuff like this. We basically put multiple pieces of data beside each other into a single type and pass that type back. And let's just take a look. Maybe I want to do, I'm going to return num plus 10 and num plus 11. And now I have to change the return signature. So it's I32 comma I32. And in this case right here, when I run it, yeah, okay. B, C, okay, well, I tried and I'm not getting there, but this is how it would look for returning. It's purely just me not receiving it properly right now. That is the error. All right, 728. Oh no. Okay. So what we're gonna do, I'm just gonna try to wrap up with a small amount of additional things here before the session's over, and then for any other questions that we have in chat, I'll be able to go through them afterwards and just go over any highlights or anything like that, or any other questions that people have. But the last thing that I want to cover in taking a look at these functions, at these function signatures and what functions look like, is that Rust has this interesting syntax where we don't always have to use a return keyword. And so, for example, right here, I'm going to remove return and I'm going to remove the semicolon, and I'm going to see if this compiles, and it runs just fine as we expect. Now, the lesson that I want to take from here on why this is the case is because it's very, very important as we go more into the functional side of Rust. The ability to not have to use the keyword all of the time allows us to make things that are a lot more compact. And when you have like a function call every line and it's doing like a whole bunch of stuff, and or maybe multiple function calls in a single line, then it becomes very, very nice to make it very compact and readable. But anyways, that's the future. For right now, the rule is that at the end of any function, the last line can be it doesn't have to have a semicolon. It doesn't have to say return, and Rust will just take whatever is there. And let's take a look at a little bit of a bigger example for that. So let new num equal num plus 10, and let's say, I'll make this mute. Add only 5 for now. So I'm gonna go like this. Add the remaining 5 now. New num plus equals 5. So it is adding 10 overall, but now I'm going to go new num. The thing I'm trying to prove here is, let's imagine there was more work. Maybe we called extra functions, maybe we did stuff here and there. But at the end, I can leave new num, which is the new variable we made. I can leave new num here on its own line, and it will do everything as I expect. And so the rule right here, I'm using the last line of the function, putting a value there, and that's what's getting returned. And so that's the same thing as saying return with the semicolon right here. And so these will both work. It's not going to complain at me for using this syntax, but we will see in certain cases how it becomes a little bit more ergonomic. Okay, so oh no, what have I done? Okay, functions. A lot more function stuff. Okay, so we're at 7:30 right now. So we're gonna end it off here for today. So thank you everybody for coming out. I'm definitely, so what would be really cool is if you found certain parts of the session like either really fun or really cool, or maybe you had an idea about what could be done differently. I'd really love to hear from people. One of the things that I was sort of surprised about during the Summer of Rust was that several people sort of like came up to me after and like, I really like the way that you did one thing, and I'm like, oh, that's really cool to hear, because I haven't really tried this much before. But do feel free to reach out to me about how any of the session stuff works today. Down the road, I definitely want to be exploring sessions that are quite similar to how we've done things today. The only fear that I have is, since I'm not walking through all of the content in the book, that I might miss something, and in the assignment it has something on it. And so if you come to anything in the assignment that you aren't sure about or haven't seen, please ask, because I'm more than happy to type up an answer for that specific question. So I'm going to stop the recording here.